In the Layer 3 So That's Where IP Lives course, we explored the network layer of the OSI model and learned about how IP affects every part of an AV design and installation. We now know that the data packet is given header information at each layer of the stack, and this course will explain how Layer 4, the transport layer, influences AV over IP data across a network. Let's put AV over IP to one side for a moment and focus on the most common sets of rules which live at Layer 4, TCP and UDP. In the world of Pro AV, most people have an idea of how these two protocols differ, but we need to begin with a very clear understanding first. TCP, or Transmission Control Protocol, is the most reliable method of transporting data from one host to another. TCP adds unique increasing counters called sequence and acknowledgement values to the header to make sure that the correct order of packets can be reconstructed before sending them up the higher layers. TCP will request the retransmission of any packets which get lost along the way to make sure this happens. TCP is all around us. We take it for granted, really. Imagine calling up the SDVoE homepage and half the text was missing. TCP makes sure that you get all the text on your screen in exactly the right order. UDP, or User Datagram Protocol, is a far quicker transport method than TCP. While a correct order sequence is important, unlike TCP, UDP will simply pass the packets it receives up the OSI stack to higher level protocols like the Layer 7 RTP or Real-Time Transport Protocol, which then implements the sequence number. So, TCP will request the resubmission of any packets which are missed, and UDP won't. So what can you do to make sure this transport process is reliable? Well, the answer to that is simple, and it applies to any type of video distribution.
The number one reason for losing data is because something is wrong with the cabling infrastructure. And this doesn't just apply to Ethernet either. It's also true for HD-base-T, point-to-point fibre transmission, SDI streams, even an HDMI cable. Bad cabling with any transport mechanism whereby data is sent from one device to another will result in data loss, period.
In SDVoE, we use both protocols, TCP for controlling endpoints and UDP for device discovery. Control is precise, therefore it's vital those control packets are managed effectively. But in the case of device discovery, every couple of seconds an SDVoE endpoint will blast a hello packet via UDP. So if one is missed, it's okay, another hello will follow very shortly. The SDVoE API server also has built-in resend mechanisms in the event it does not receive a command reply from a targeted endpoint within a certain time. If after a few resend attempts there is still no reply, an error notification will be sent to the control software. In addition, SDVoE have created their own technology which allows it to make decisions if it discovers any missing pixels in a frame. Taking advantage of the fact that in real video, a pixel is likely to be very similar to pixels near it in space and time from the previous frame, SDVoE devices will patch over any missing pixels by using data from the previous frame or from the line above the missing pixel. This feature is extremely important when features which don't have a frame buffer are used, such as gen locking, because the receiver has to maintain the sync with the display. This would only happen in the rare case that pixels are actually lost, which shouldn't happen if you tested your cable infrastructure correctly. And the patch, which equates to about 1/8 of a line of video at 4K, will only be seen on screen for around 16 milliseconds at 60 Hz, almost always totally undetectable. Contrast this to the flashing and black screens that occur when matrix switches or other AV over IP systems lose data, and we can see how SDVoE technology can support those rare instances where you didn't spend enough time checking your cabling infrastructure first. The immediate benefit of SDVoE is that as a full stack solution, it's designed to be as robust as possible, just as Ethernet was designed to be long before AV over IP came along. SDVoE have taken this reliability even further by building specialty AV-focused fixes on top of the already robust OSI stack, ensuring that the user experience is flawless and consistent across all SDVoE systems, large or small.